Welcome to our channel. Today we're diving into some fascinating and little-known facts about our solar system. From the heart of our sun to the icy outskirts of the Kuiper Belt, we're about to uncover hidden wonders and cosmic secrets. So buckle up, space fans, and get ready for an exhilarating ride through the cosmos. Let's kick things off with our local star, the sun. The photosphere is the layer we see, the visible surface of the sun. But here's where it gets really interesting. The corona, the outermost layer, can reach temperatures of millions of degrees Fahrenheit. That's hundreds of times hotter than the sun's surface. It's a bit of a head-scratcher for us scientists, this whole corona heating problem. The leading theory involves magnetic fields, but the exact mechanism is still being debated. Next up is Mercury, the smallest planet and the closest to the sun. Mercury actually harbors a secret ingredient in some of its craters: ice. That's right, water ice, hiding in the shadows of craters that never see a single ray of sunlight. These craters, located at Mercury's poles, act like cosmic cold traps. Billions of years ago, comets and asteroids carrying water ice impacted Mercury. And because Mercury has a very thin atmosphere, there's nothing to trap heat, so the ice remains frozen. Let's move on to Venus, often called Earth's sister planet because of its similar size and composition. But don't let that fool you. Venus is a world of extremes, with a toxic atmosphere and surface temperatures hot enough to melt lead. And if that weren't strange enough, Venus rotates in the opposite direction to most planets in our solar system. This retrograde rotation means the sun, if you could see it through the thick Venusian clouds, would rise in the west and set in the east. Some scientists speculate that it might be the result of a massive collision early in Venus's history, essentially flipping the planet upside down. It's a stark reminder that our solar system is full of surprises. Now, you might think Earth has just one moon, our trusty companion in the night sky, but did you know that Earth has a second moon? Well, sort of. It's not a moon in the traditional sense, but rather a quasi-satellite. This quasi-satellite, known as 3753 Cruithne, is an asteroid that's gravitationally bound to our planet. But here's the catch. It doesn't orbit Earth in a neat elliptical path like our moon. Instead, it follows a horseshoe-shaped orbit around the sun, and from our perspective on Earth, it appears to loop around us in a complex dance. Let's journey to the red planet Mars, a world that has captivated our imaginations for centuries. Now, you might picture Martian sunsets as a fiery red, given the planet's rusty hue, but here's a surprise. Sunsets on Mars appear blue. It all comes down to the way light interacts with the Martian atmosphere. On Earth, our atmosphere scatters blue light more effectively, which is why our sky looks blue. On Mars, the thin atmosphere, filled with dust particles, actually scatters red light more effectively. So, during the day, the Martian sky takes on a reddish hue. But at sunset, the blue light is scattered less, creating a cool blue halo around the setting sun. Next up is Jupiter, the largest planet in our solar system, a gas giant with a swirling tapestry of clouds and storms. One of its most iconic features is the Great Red Spot, a massive storm that has been raging for centuries. This storm is so large that you could fit 2 to 3 Earths inside it. The exact reason for its reddish color is still a mystery, but scientists believe it might be due to the presence of certain chemicals in Jupiter's atmosphere. The Great Red Spot is a testament to the powerful forces at play in Jupiter's atmosphere. Now let's talk about Saturn, the ringed wonder of our solar system. Saturn's rings are truly a sight to behold, but here's a fact that might surprise you. Saturn is less dense than water. Saturn's low density is due to its composition, which is primarily hydrogen and helium, the lightest elements in the universe. It's a fascinating example of how even the largest objects in our solar system can be surprisingly light on their feet, or rather their rings. Let's head out to Uranus, the ice giant that's tilted on its side. While most planets in our solar system spin on their axis with a slight tilt, Uranus takes the cake with an axial tilt of almost 98 degrees. That means Uranus essentially spins on its side like a rolling ball. This extreme tilt gives Uranus the most extreme seasons in our solar system. The exact cause of Uranus's extreme tilt is unknown, but it's thought to be the result of a collision with a large object early in its history. Our last stop takes us to Neptune, the farthest planet from the Sun. Neptune is known for its deep blue color, a result of methane in its atmosphere. But what really sets Neptune apart is its wind. Neptune is home to the fastest winds in our solar system, with speeds reaching over 1,200 miles per hour. These winds whip around the planet at incredible speeds, creating massive storms that can dwarf Earth. This internal heat, combined with the planet's rapid rotation, is thought to drive the powerful winds that we observe. And finally, we come to Pluto, the dwarf planet that captured our hearts. Though reclassified as a dwarf planet, Pluto still holds many mysteries, including a giant heart-shaped glacier on its surface. This glacier, formerly known as Sputnik Planitia, is made of nitrogen, methane, and carbon monoxide ices. It's thought to be relatively young, geologically speaking, and its smooth surface suggests that it's still geologically active. Despite its small size and distance from the Sun, Pluto is a reminder that even the most distant objects in our solar system can be full of wonder and surprise. Thanks for watching. If you enjoyed these mind-blowing facts about our solar system, don't forget to like, subscribe, and hit the bell icon for more amazing content. Keep your curiosity burning bright and never stop exploring the vast unknown. See you next time for another cosmic adventure.